What if? I told you that 252 million years ago, our planet suffered a true apocalypse. A silent, slow-motion chemical execution so thorough, so complete, that it makes the dinosaur killer look like a minor fender bender on the highway of life. This was not just an extinction. This was a planetary reset button. An event so devastating scientists don't just call it an extinction, they call it the Great Dying. The asteroid that killed the dinosaurs was a brutal, swift assassin. It wiped out roughly 75% of all species on Earth. A horrific number, but the Great Dying. It was a patient, methodical serial killer. It didn't kill 75%. It killed 96% of all marine species. It killed 70% of all land vertebrate species. This is a fact that shocks most people. We are so focused on the dinosaur story. Why do you think the bigger, deadlier extinction is the one nobody talks about? Is it because it didn't have a single dramatic villain like an asteroid? Let's start the investigation in the comments. So what was the weapon? If it wasn't a rock from space, what could possibly cause a murder on this scale? And the killer wasn't an external force, it was an inside job. The killer was the Earth itself. The crime scene begins in what is now Siberia, but there is no impact crater. Instead, there is a vast blackened scar of volcanic rock the size of Western Europe, a geological feature known as the Siberian Traps. This was not a single explosive volcanic eruption. This was a planetary wound that bled fire. For 1 million years, the ground itself split open and relentlessly poured out an ocean of lava. But the lava wasn't the weapon. The lava was just the symptom. The real weapon was the gas. The unimaginable volume of carbon dioxide and methane that was released into the atmosphere, triggering a runaway greenhouse effect. But even that isn't the full story. The heat didn't kill them. The lack of air did. This is not a simple story of global warming. This is a complex, multi-stage chemical assassination that turned the very oceans that cradle life into a toxic, suffocating purple soup. In this video, we are deconstructing the greatest crime scene in the history of our planet. We will show you why a million-year-long volcanic eruption in Siberia was just the trigger. We will deconstruct the horrifying three-step chemical chain reaction that suffocated the oceans, poisoned the air with the smell of rotten eggs, and made the rain fall like acid. And we will reveal the most surprising twist of all the identity of the survivors who rose from the ashes of this near-total extinction to become the next rulers of the Earth. The dinosaurs. Are you ready to investigate the day life almost ended? Our investigation begins 252 million years ago in the late Permian period. The world is a single giant supercontinent called Pangaea. Life is flourishing in ways we can barely imagine. Vast, lush forests cover the land, and the oceans are teeming with a bizarre and wonderful diversity of creatures. But deep beneath this vibrant world in the planet's molten heart, a killer is stirring. What followed was not an eruption in the way we think of it, it was a flood. A flood of basaltic lava pouring out of these massive fissures, not for a day or a week, but for nearly 1 million years. This is the Siberian Traps. Let's try to comprehend that scale. The volume of lava that erupted is estimated to be over 4 million cubic kilometers. That is enough molten rock to bury the entire continental United States under half a mile of lava. It was a geological event of such magnitude, it literally changed the face of the planet. Imagine the most powerful volcanic eruption in recent history, like Mount St. Helens in 1980. The Siberian Traps released enough lava to equal one Mount St. Helens eruption every single day, for over 60,000 years straight. But as we've learned at Y-Zone 360, the immediate fiery destruction is rarely the real killer. The lava flows of the Siberian Traps were a regional catastrophe, yes. They incinerated everything in their path, but they could not kill 96% of life in the ocean on the other side of the world. The lava was just the symptom. The true weapon was invisible. It was the gas. As this ocean of lava burned its way through the carbon-rich coal beds and sedimentary rock of ancient Siberia, it released an astronomical amount of greenhouse gases into the atmosphere. Primarily carbon dioxide, CO2, and methane CH4. This was the trigger for the first phase of the global extinction runaway global warming. The delicate balance was shattered. Scientists estimate that the average global temperature soared by 5 to 10 degrees Celsius. The poles, once cool, became temperate. The equator became an uninhabitable, superheated death zone. But this initial warming, as devastating as it was not the main event. It was just the setup for the real killer. But why did this heat lead to a global suffocation? How did the oceans teeming with life run out of air? The atmosphere is burning, the land is scorching, but the true catastrophe, the one that earns this event the name The Great Dying, is happening beneath the waves. To understand how an entire ocean dies, we need to look at a simple, invisible relationship between temperature and life's most precious resource, oxygen. You see, water holds oxygen. It's dissolved in there like bubbles in a soda. This dissolved oxygen is what allows fish, sharks, trilobites, and every other marine creature to breathe. But here is the critical rule of chemistry that doomed the Permian world: warm water cannot hold as much gas as cold water. As the global temperature soared due to the greenhouse effect, they absorbed the heat from the atmosphere, and as the water warmed, it started to lose its ability to hold on to oxygen. The gas simply escaped into the air. This was the beginning of ocean anoxia, a global suffocation event. Imagine being in a crowded room where the air is slowly being pumped out. At first, you breathe a little faster. Then you start to feel lightheaded. Then panic sets in as you realize there isn't enough air for everyone. That is exactly what happened to the marine life of the Permian. The circulation of the ocean, the currents that normally bring oxygen-rich water from the surface down to the depths, began to stall. The creatures that needed the most oxygen, the active hunters, the complex predators, were the first to go. They gasped for breath in water that offered none. The extinction began at the top of the food chain and worked its way down. But the loss of oxygen was only the first phase of the ocean's death. As the oxygen levels plummeted towards zero, something else began to happen, something far more sinister. Nature abhors a vacuum. When one door closes for life, another opens. And in the stagnant, oxygen-free depths of the Permian Ocean, a different kind of life began to stir. A life that didn't need oxygen. A life that thrived in the rot and the decay. The anaerobic bacteria. These ancient microbes had been hiding in the shadows for eons, suppressed by the oxygen-rich world. But now, with the oxygen gone, their competitors dead, and the water warm and stagnant, they exploded in numbers. They took over the oceans. And these bacteria have a deadly byproduct. They don't exhale carbon dioxide like us. As they consume the rotting organic matter of the dead world, they release a gas that is lethal to almost all other forms of life. Hydrogen sulfide, H2S. This gas is not just toxic, it is a chemical weapon. It smells like rotten eggs, but at high concentrations, you don't even smell it, it just kills you. It attacks the nervous system and stops cellular respiration. So the oceans are purple, the water is toxic, the marine world is effectively dead, but the horror didn't stop at the shoreline, because gas doesn't stay in the water. Eventually, the concentration of hydrogen sulfide became so high that it began to bubble out of the ocean and into the atmosphere. The poison was coming for the land. The animals on the continents had survived the heat. But could they survive a sky that had turned against them? Could they breathe air that was slowly being replaced by a nerve agent? The weapon has been forged in the deep, now it is about to be unleashed on the surface. The ocean has become a chemical weapon factory. Trillions of tons of hydrogen sulfide gas are bubbling up from the purple depths, escaping into the atmosphere. The killer has breached the shoreline. For the creatures living on the supercontinent of Pangaea, the world was already a nightmare of extreme heat. But now the air itself began to change. Imagine the smell. Hydrogen sulfide has the distinct repulsive odor of rotten eggs. At first, it would have been a faint, unpleasant whiff on the breeze, but as the bacteria in the ocean multiplied, the concentration grew. The entire planet began to smell of death and decay. For the animals of the Permian, the giant amphibians, the mammal-like reptiles, there was no escape. They would walk into a valley seeking water or shade, only to walk into a silent kill zone. The gas attacks the respiratory system, shutting down the body's ability to process oxygen. They didn't just die, they were chemically asphyxiated. The land became a graveyard. Some of it rose high into the upper atmosphere, and there it attacked the Earth's most critical defense system, the ozone layer. Just like in our gamma ray burst scenario, the ozone layer was shredded, the Earth's sunglasses were shattered, the sun's lethal ultraviolet UV radiation poured down onto the surface unfiltered. So now the survivors on land were facing a triple threat: extreme heat, poisonous air, and now radiation burns. Plants withered, animals went blind, DNA mutated. The surface of the Earth was being sterilized. But the assault wasn't over. The Earth had one final weapon to unleash the coup de grace for any life that was still clinging to existence: the acid rain. Remember the Siberian Traps? They were still erupting. They had been pumping sulfur dioxide into the atmosphere for thousands of years. When this sulfur mixed with water vapor in the clouds, it created sulfuric acid, and when it rained, it didn't bring life, it brought destruction. It rained acid, strong enough to strip the leaves off trees, strong enough to dissolve the nutrients in the soil, leaving the land barren and unable to support plant life. This was the final blow to the food chain. No plants meant no herbivores. No herbivores meant no carnivores. The forest of Pangaea, once lush and green, turned into rotting fungal wastelands. The world was dead. 96% of all marine life, 70% of all land life, gone. The great dying was complete. The Earth was a hot, poisonous, acidic, silent rock. It was the closest our planet has ever come to becoming like Venus, a runaway greenhouse world where life is impossible. The story didn't end. In the darkest corners of this hellscape, amidst the rot and the poison, a few sparks of life refused to be extinguished. They were the ultimate survivors, the toughest, most adaptable creatures the world had ever seen. When the smoke finally cleared millions of years later, a new cast of characters emerged from the shadows. These were the survivors of the Great Dying. Let's meet the champion of this new harsh world, Lystrosaurus. It doesn't look like much. It's a squat, pig-sized herbivore with a beak like a turtle. But for a few million years after the extinction, this humble creature was the king of the world. It made up 95% of all land vertebrates. Why? It was a burrower. It lived underground, escaping the heat, the gas, and the acid rain. It wasn't picky. It could eat the tough, dry roots and tubers that survived when the leafy plants died. It had powerful lungs. Studies suggest Lystrosaurus had adaptations to breathe efficiently in the low-oxygen atmosphere of the post-apocalyptic world. But Lystrosaurus was just the placeholder, the bridge between the old world and the new. Because alongside it, another group of survivors was quietly evolving. A group of small, agile reptiles known as archosaurs. The Permian extinction had left the world hot and dry. The archosaurs developed a new way of breathing, a unidirectional airflow system in their lungs that was incredibly efficient at extracting oxygen. From this humble stock of survivors, evolution exploded in a riot of new forms. Some returned to the water and became the terrifying sea monsters like ichthyosaurs. Some took to the skies and became pterosaurs. And some stayed on land, grew larger, stronger, and more terrifying, evolving into the most famous group of animals in history, the dinosaurs. This is the ultimate irony. The Great Dying, the event that almost killed everything, was the very thing that made the age of dinosaurs possible. If the Great Dying hadn't happened, do you think dinosaurs would have ever evolved, or would the world still be ruled by giant amphibians and mammal-like reptiles? Let us know your alternate history theories. And this brings us to the final chilling realization. The Great Dying wasn't a one-time event. It was a lesson in planetary physics. We look back at the Permian extinction as ancient history. But if you look at the data today, the rising temperatures, the ocean acidification, the dead zones, it starts to look less like history and more like a warning. In our final part, we will ask the question, could it happen again? Now let's look at the world today. Ingredient 1, carbon dioxide. In the Permian, the CO2 came from volcanoes burning through coal beds. Today it comes from us burning through coal oil and gas. The source is different, but the molecule is the same. And the rate at which we are pumping it into the atmosphere is actually faster than the volcanoes of the Siberian Traps. Ingredient 2, global warming. The Permian world heated up by 5 to 10 degrees. We are not at Permian levels yet, but we are moving the dial in that direction. The ice caps are melting, the permafrost is thawing, the feedback loops are starting to spin. Ingredient 3, acidification. Our oceans are absorbing a huge amount of our excess CO2. This is turning the water acidic, just like in the Permian. We are already seeing coral reefs bleaching and shellfish struggling to build their shells. The chemistry is shifting. Ingredient 4, deoxygenation. This is the most chilling parallel. Dead zones, areas of low oxygen where marine life cannot survive, are expanding in our oceans right now. But there is one critical difference between us and the volcanoes of Siberia. The volcanoes were mindless geological forces. They couldn't stop. They couldn't think. They couldn't change their behavior. We can. We are the first species in the history of this planet that has the power to understand the mechanism of its own potential extinction. This puts a heavy burden on our shoulders. Do you believe humanity has the will to change course before we hit the tipping point? Or are we destined to repeat the mistakes of the past? The story of the Great Dying is a story of fragility. It teaches us that our biosphere is not indestructible. It can be poisoned, it can be suffocated, it can be broken. The Great Dying was the end of the old world. Let's make sure it doesn't become the prophecy for ours. At Y-Zone 360, we deconstruct these nightmares not to paralyze you with fear, but to arm you with perspective. To show you the stakes of the game we are playing, because understanding why the world died once is the only way to ensure it never dies again.